Most solar systems fail before they are even installed, and it is not because the inverter is bad, not even because the solar panels are fake or because the batteries are fake, but in most cases it is because the load analysis was done wrongly. Welcome to today's lesson, and in this lesson I will show you the exact step-by-step method professionals use to conduct a proper load analysis for solar system design. In this lesson, we'll cover the following topics. We'll cover how to list your appliances correctly, how to calculate your total power consumption, how to also calculate your daily energy usage. This lesson is for solar installers, technicians, students, or someone trying to understand solar design properly. And now let's begin. Before we start sizing solar system, the first thing you must do, or as an installer, the first step you are supposed to take is to understand your load. Since you are designing your solar system to fit those loads, you must first of all understand the loads that you are designing for. And that is why we are discussing load analysis. Load analysis simply means calculating how much electricity your appliances consume. It is a process or the procedure of calculating the total electrical energy consumed by appliances in a building. So when you hear people talking about solar is all about calculation, this is the calculation that we are talking about. It is load analysis. This is where the calculation take place. You list your appliances, you know their wattage, you know their power consumptions, as we are going to look at in the subsequent slide. Load analysis will help to determine the following: your battery size, it will determine your inverter size, your solar panels, as well as your backup duration. Now, the first step in knowing your appliances is identifying all your appliances, their names, their quantity, wattage, and how many hours they are being used in a day. Now, for this example, this is a small example of how a load analysis table should look like. Now, from this example, you can see the first column is our appliances, and the second column is their quantity. The next column is their wattage, that's their power consumption, and the next is their total wattage. The next column is how many hours they are used in a day, and the last column is their daily energy consumption, which is in watt hour. Now, for this appliances name, this for your appliances name, this appliance's name is tied to this column, their quantity is tied to this column, their wattage is tied to this column, their usage or their how many hours they have been used in a day is also tied to this column. Now, for this our appliances name, you can see we have televisions, we have fans, we have LED bulb, and for their quantity, for this television we have 2 televisions, for the fans we have 4 fans, for the LED bulbs we have up to 10 LED bulbs, and their wattage is 100 watts. Each television, that's wattage per item, wattage per each television, wattage per each fan, wattage per each LED bulb. So their wattage for this television is 100 watts. For each fan, the wattage is 75 watts. For this LED bulb, their wattage is 12 watts. Now we skip this column because we are discussing this one in our next step. So the next thing is the how many hours these appliances are run. As you can see, for television they run for 5 hours. The fans run for 8 hours, in a day. The fans runs for 8 hours, and for LED bulb for 6 hours. Now, always check the appliance nameplate in order for you to get the accurate wattage. Do not assume that these appliances will consume maybe 100 watts, 200 watts. Do not assume. Always check the appliance nameplate. You can mostly see it at the back of the appliances or at the side beside the appliances. So always check for it. Do not use Mr. A appliance for Mr. B, because Mr. A is using maybe Hisense television 65 inches, and Mr. B is also using 65 inches LG televisions, and you assume their power consumption is the same. Each brand may have different power consumption, so always look at your appliance nameplate. And for this how many hours those appliances are run in a day, you are not getting this one on the nameplate. You ask your client how many hours does he use his appliance in a day. So it is your client that will give you this data, how many hours he uses televisions, how many hours he uses his fan in a day, how many hours he uses LED bulbs in a day. So it is your client that will give you this data here, this particular one. This wattage, you get it from your appliance nameplate. This one you get it from your client. And this one we discuss this energy and total wattage in our next slide. Now step 2 is calculating total appliance power. When we talk about total appliance power, that is total power consumption of all your appliances. The formula for this is for your total appliance power is the quantity of your appliances multiplied by the power of your appliances. Example, we have 2 televisions, which is our quantity. We have 2 multiplied by the power consumption of for each television, which is 100 watts. It will give us 200 watts. For our fans, we have 4 fans, which is our quantity. We multiply this quantity times the total power consumption for each fan, which is 75 watts. It will give us 300 watts. Now you do the same for each of your appliances. Now our total appliances will be this 200 plus 300, as you can see here. 200 for the televisions and 300 watts for the fans, which is 500 watts. Our total power will be this 500 watts for this particular example. So always remember to multiply the quantity of your appliances by the power consumption of those appliances in order to get the total power. And as you can see from this example, is quantity multiplied by power. Now this is the column that we are trying to find, which is the total wattage. In order to find this, we multiply this one and this one. So you multiply your quantity times the wattage. You can either multiply the wattage times the quantity or the quantity times the wattage. It will still give you the same figure. So when you multiply these televisions, which is 2 times 100 watts, it will give us 200 watts. For the fans, we have 4 fans. Multiply this 4 times 75 watts to give us 300 watts. For the LED bulbs, we have 10 LED bulbs, and each of this LED bulb is 12 watts. So when you multiply this 10 times 12 watts, it will give us 120 watts. The next step is calculating your daily energy consumption. Your daily energy consumption will depend on your appliances wattage as well as the run time. When I talk about when I said run time, means how many hours does that appliances run in a day. If your appliances is 100 watts and is running for 5 hours, it is that 5 hours that will determine its energy consumption. If it is running on lesser hour, it will also determine, it means that it is consuming less energy in a day. The higher the hours, the number of hours, the higher the daily energy consumption. The lower the hours, if it is 1 hour, it will not consume a lot of energy. If it is 10 hours, the more the hours, the more the energy consumption. That's all I'm trying to say. And the formula for calculating your daily energy is your total wattage times the number of hours those or that particular appliances is running. For this example, we have TV. The total watts for this TV, the total wattage is 200 watts, and it's running for 5 hours. So when you multiply this 200 times 5, it will give us 1000 watts hour. For the fans, which is 300 watts, running for 8 hours, when you multiply 300 times 8 hours, it will give us 2400 watt hour. So that's how you can calculate your daily energy consumption, by simply multiplying your total appliance wattage by the number of hours, or the number of hours you intend or your client intend to run those appliances. Now for this particular example, our total energy consumption will be the energy consumption of television plus the energy consumption of fans, which is 1000 watt hour plus 2400 watt hour, and it will give us 3400 watt hour per day. So when we run these televisions and fan for this number of hours, they will consume this they will consume this energy in a day. When they are run for these hours, they will consume this energy. That's 3.4 kilowatt or 3400 watt hour. So as you can see, this is from our table. In order to find this column, we multiply this column and this column. That's our total wattage by the number of hours we are running our appliances in a day. So for this for this television, which is 200 watts, how do you get this 200 watts? You get it by multiplying the quantity and the wattage. Please don't forget this. We get this total wattage by multiplying the quantity and the wattage. Wattage is the power consumption of this television. So we multiply the quantity of the television by the power consumption of the television. That's how we get this total wattage. And now we are looking for the daily energy consumption, which we multiply the total wattage by the number of hours. So this television is running for 5 hours, and it will consume 1000 watt hour. Sorry, there's a zero here. This is 1000. This is not 100 watt hour. It is 1000 watt hour. So for the fans, we have a total energy consumption of total wattage of 300 watts, and our clients want to run this for 8 hours. So the fan will consume the total energy of 2400 watt hour. For these LED bulbs, our clients want to they consume, their total wattage is 120 watts, and our clients want to run it for 6 hours. So when you multiply this 120 times 6 hours, it will give us 720 watt hour. So always take note of this. Let me recap a bit. In order to know your daily energy consumption, you multiply your total wattage by the number of hours you are using those appliances. And for you to know your total wattage, you multiply the quantity of your appliances by their power consumption or their wattage. So two appliances, two televisions consuming 100 watts will give you 200 watts. If you run them for 5 hours, it will give you 1000 watt hour. Like I said earlier, this is 1000, not 100 watt hour, is 1000 watt hour. Now after everything, this is how a good, or how your load analysis table is supposed to look like. For this example, for this my own, you can see these are all my appliances, and please take note that these are the ones that our client or your client wants to run them on solar. Any other appliances that is not included here, it means it's not going to run on solar. So make sure that it is only those that you intend to connect them to your solar that is listed here. Any appliances that is not here is not going to be connected. So even after your load analysis and when during your installation, if you have not added any appliances here, do not connect it to your solar. Make sure that you always remember that. And the next column is the quantity, the number of our appliances. The next column is their wattage, that's their power consumption, which is in watts. So this is where we are going to list them. And the next one is the total wattage of our appliances. The next one is their running hours, or run hours, anyone, how many hours the clients want to use each of these appliances in a day. And the last column is their energy consumption. For each of these appliances, this is their energy consumption in the last column. Let me erase this. So you can see our television. Just for a recap, our televisions, we have 2 televisions. Each of these television consume 100 watts. Then the total watt of these 2 television will be 2 times 100, which is 200 watts. And they are running for 5 hours, which will multiply this and this. So we multiply this 200 watts by 5 hours, it will give us 1000 watt hour. For our fans, we have 4 fans, and their wattage is 75 watts per item. That's per each fan is consuming 75 watts. When you multiply 4 times the wattage, which is 75, it will give us 300 watts. And they are running for 8 hours. When you multiply 300 times 8 hours, it will give us 2400 watt hour. You do the same thing for this LED bulb, 10 pieces. They are running for their wattage is 12 watts, and their total wattage should be 10 times 12, which is 120 watts. And they are running for 8 hours. Their total energy, that should be 120 times 8 hours. That's 960 watt hour. Now there's something I want to draw your attention to. When you are conducting your load analysis, sometimes you feel like some of these appliances are too small, so you will not include them during your load analysis. And then you just went ahead and design your system and you install it. After you install it, you discover that the battery is draining faster. You now begin to wonder what is draining this battery. The problem is maybe you overlook these bulbs because you think these LED bulbs, because you think they are just 12 watts. You overlook them. But when they gather together for 8 hours, running for 8 hours, they consume almost 1 kilowatt hour. See, they consume 960 watt hour. So that's why when they tell you, and when they said solar is calculation, this is the critical part of the calculation. Sometimes you overlook, or you think this appliances is too small, so you don't include it. You think when you size your system, it will power it up, and then it is those that you refuse to include, they are the one that will start stressing you. Things like this LED bulb, things like this Wi-Fi. For instance, for this Wi-Fi is just one, and is just 15 watts running for 24 hours. It consumes almost 360 watt hour in a day. You can see laptop, all this small one, phone, 4 phones. The phone is 18 watts. You see it's consuming 216 watts. So all these small appliances, when you gather them together, they consume a lot of energy. You can see this one. Let's assume you do not include this one. You do not include these laptops. You do not include these phones because you think they are small. Now when you multiply this, so when you sum this one, let me clear this drawing. Let's assume you didn't include this LED bulb because you think they are small, and this Wi-Fi because you think it's just 15 watts, and these laptops because you think it's just 65 watts, so it's not much, and the phones you think the phone is just small. Now if you not include this one, and if you multiply if you sum all of their energy consumption, this one, and this one, and this one, you see that they are consuming more than 2 kilowatts of energy, which is very bad if you do not include them because you are thinking they are too small. So all I'm trying to say is, no matter how small those appliances are, always include them. If you are not going to include those appliances, then make sure you oversize after everything. Make sure you oversize the energy, the daily energy. Make sure you add some extra margin in order to cover for all these appliances that you did not mention. So always take note of that. And like I said earlier, anything that is not here should never be connected to your solar system. Anything that did not include here should never be connected. If your client say okay, he wants to add additional AC after you calculated or you use 2 AC, then the client say he wants to add additional AC, then you should come back here and add that additional AC before you go and carry out your installation. So make sure you take note of all this. Now, after you have done with all your calculations and all your figures are right, the next stage is to sum all of this column to your total wattage. You sum everything together, as well as your daily energy. You sum everything together. You sum all of them together. So for this total wattage, which is 3,507 watts, that's our total wattage. It is this one that you use when you are sizing your inverter. You use this one to size your inverter. And for your daily energy consumption, which is 23,276, you use this for sizing your solar panels and your battery bank. So always take note of that. Your total wattage is when you sum all your total wattage, you use that figure for your inverter, and this one you use it for your battery bank. That's your daily energy and your solar panels. So for this one, how to size inverter for this load, I'm going to do a video on that, so make sure you are following. I also do a video on how you can size solar panel and battery bank for this particular load analysis, for this particular figure. So make sure you are following. Thank you for watching, and make sure you subscribe to this channel for more videos like this. If you have any question, if you have any suggestion, please make sure you drop them in the comment section. Thank you very much and remain blessed.